Welcome to this webinar. I'm going to talk about Spring Data Neo4j today. This talk will be an intro-level talk, so no advanced topics, but it's about graphs, graph databases, Neo4j, how to get started with Spring Data Neo4j. And for that, despite having Cineasts in the announcement, I'd like to choose something more interactive as sample application, which is a Twitter graph app, which uses the search functionality of Twitter and Spring Social to pull tweets out of Twitter and put them into a graph so that we can later look at it. Then at the end there will be some resources and we'll answer the questions. But also my colleague Lasse is on board and will answer your questions on the fly. So feel free to type in as many questions as you'd like. So he's busy during the next hour. Let's see. First, I want to encourage you to become part of today's Twitter graph. And you can easily do that by just tweeting with the hashtags Neo4j and SDN. And you can tweet about, for instance, your attendance, about questions you have, remarks about the webinar or the content, or whatever you like to tweet anyway. So, and we will take your tweets and put them into a graph and then see what comes out of that. So my next big topic will be about graphs. And I hope sorry for the lag. It's between Germany and the US, it's a bit laggy. So I want to talk about that you can find graphs and graph data everywhere. Graph data is actually connected data. So it not only focuses on entities and their attributes, but also as much on the connection between the entities. As we know that lots of information and insight lies between things and not just in the things themselves. So I want to have a quick look at several areas of our life actually, and where we can find graphs and graph data. So first, it's in the sciences. So most of the sciences deal with things and the connection between these things. For instance, you have in biology and chemistry, you have the elements, you have proteins, you have genes, which are heavily connected and which are also depending in their reactions on their environments and lots of variables, and everything somehow influences anything else. And but also in all the other sciences. Another example is history, where you have all the events that happened in history and which are all connected, as you learned at school. And of course, today's politics is also influenced by the past events and also influences how we see history. And so many things in politics are connected. All the parties, the politicians, their decisions, our laws, and our own society. Everything is really rich information, but very, very connected. Another important aspect of graph data is also that it's semi-structured, so it's doesn't adhere to a strict schema, but instead has attributes depending on the real world and where it comes from and which environment you look at. Society is a lot about us, our social networks, and I'm not talking about the virtual social networks here. It's about our families, our friends, our neighbors, our work environment, our colleagues. And we have a rich set of connections to each of those people and also indirectly into all the other second and third level people that we're connected to. So whoever deals with this kind of data is also working with graph data. Then, of course, you're right now connected to the internet. All the things there, all the computers, all the devices, all the services, all the users form a richly connected network, and not just the data they work with, but also the things themselves. So we have lots of customers who work with server infrastructure and networking infrastructure and actually manage their inventory of devices in a graph and see, for instance, when something fails where it fails and how it cascades and so on. So it's a very natural data model in these kinds of areas. Of course, also in business, you deal with a lot of data, and so far we often tended to kind of either cut down or dump down our data to fit into rigid models. And with something like a graph database, you're not forced to do that anymore. You can have much looser constraints and actually focus on the things that are important. For instance, using the attributes of an entity that are there and not arbitrarily creating placeholders or things like that, and also focusing on the relationships that are there, which will be actually enforced in a graph database, unlike optional relationships in other data models. And last but not least, there's all the arts. We have lots of visualizations that are very graphic, especially in recent times. You have all these infographics which are often visualized as a graph. Every time we are creative and we are doodling, mind mapping, brainstorming, or even drawing entity relationship diagrams, you're actually creating graphs, which is quite interesting. And of course, in stories, there are lots of people and events and things that happen which are richly interconnected. And if you look at some of the latest fantasy work, there are hundreds of people connected in these stories, and that's a really nice graph application to work with these. For managing graph data, you need a graph database. So that's a database which is dedicated to manage this kind of connected data. So first of all, we have nodes in a graph database, which form the basic element, and those nodes are connected with relationships, which are first directed, which means that they point from one node to another, but they're always traversable in the opposite direction as well. And they are typed, so they have a label. For instance, a nose relationship between two people. And then we have both on nodes and on relationships, we have key value, arbitrary key value properties. So I can put as many key value attributes on a node and on a relationship and on the other node, depending on my domain model, and the actual data I want to represent. One of these graph databases that are around somehow, especially in 2012, every other week, a new graph database pops up, which is really nice because you get more and more ways to manage your graph data. One of these graph databases is Neo4j. And Neo4j is a typical graph database. That means it actually manages nodes, graph data which are recorded in nodes, which are connected by relationships. And as I said, both have properties. And the next interesting question is not just how to put it in there, but also how to get it out, which is in a graph database by traversing the graph. So you grab one node, one start node, which is actually quite often the case that you have a real-world start node in your applications. So be it people that you start from, or orders, or a movie, or an application, or a product, or a tag or category. You often have a starting point where you start your traversal in the graph, which is the fastest graph operation and is the core operation in the graph. And the traversal then returns your path into the graph, which you can use in your application to do your business logic. The start nodes of the traversals are retrieved with an index system, which is, for instance, in Neo4j, it's an integrated index system and uses Lucene by default. And that helps you to find nodes or relationships indexed by their properties and start the traversals from there. So some words about Neo4j itself. Neo4j is written in Java. It uses some nice high-performance Java features like memory mapped I/O, and so performs very nicely on all platforms. Neo4j can run as an embedded database like HSQL, and it also can run as a server database. And so we have the opportunity to use either JVM languages like Java, Scala, Ruby, Clojure to run with the embedded Neo4j instance, or we can use all these languages and many more, like Ruby, JavaScript, and so on, to run against the Neo4j server via an HTTP protocol. Neo4j also runs on cloud provider instances like on Heroku or Amazon, and also on Cloud Foundry, but not the public Cloud Foundry instance. Neo4j as a graph database has is transactional. It provides ACID transactions like a relational database, and that's because unlike other NoSQL databases, it has no natural aggregate boundary like a document in a document database. So Neo4j or a graph database is very fine-grained, so the nodes and relationships are very fine-grained elements, and whenever you do operations on them, you want them to be transactional. So either all the changes happen that you did or none, because you don't want to have half-finished nodes or half-finished relationships somewhere where only a part of the graph got updated and the other part didn't. So it's transactional, and actually in Spring Data Neo4j we use just the transactional annotations and the transaction management that comes with the Spring framework to provide that as well. As I said, Neo4j integrates an indexing subsystem to find start nodes for queries and traversals, which comes by default as with Lucene. And on a single instance, it scales to 34 billion nodes and relationships. So each of them are 34 billion. And on commodity hardware like my old MacBook here, it already runs with 1 million hops per second. And on dedicated hardware, server hardware, it's much faster even than that. And for high availability, Neo4j comes with a master-slave cluster setup, which you can use either for making your system highly available, or also for read scaling by scaling out the reads to a cluster of slave machines, for instance. That's some words about Neo4j. Oh, it's licensed like MySQL. So you have a GPL Community Edition and a GPL Enterprise Edition, which also comes with a commercial license. So you're free to use it in the GPL Community Edition for your applications, either in your own environment or on the server side. And for the enterprise version, it's AGPL. So it's for open source, free for open source. Today, we want to look at the Twitter graph. So I start with the domain model. And the best way to write a domain model or create a domain model for the graph database is to actually whiteboard it. So you grab your colleagues, a pen, a whiteboard, and start doodling. And the doodles become your graph after that. So you can do it in the abstract way, so by talking about what do I need in my application, in my domain. So in our domain, it's tweets. It's people who posted these tweets, so users, and it's also text, because in the hashtags in each tweet form text that tweets can search by, for instance. And so I have the posted relationship between the user and the tweet, and the text relationship between the tweet and the tag. And then we have also, if you mention someone in the tweet, then you have a mentions relationship from a tweet to a user again. And this already enables us to do lots of interesting queries on top of that. I will show some in a few minutes. Of course, you can also do the whiteboarding not with abstract concepts. You also can start from concrete data that you have. So in our case, it's the actual tweets, which have a poster, so an author who posted it. Then they actually have tags, which you can already see in the tweet text, and we'll be referring to those. And lastly, we have the mentions, because the one tweet mentions my Twitter account, so it mentions me. So this is how you would go ahead and develop your graph domain model. I already said that even the simple domain model already allows us to do some very advanced queries and analytics for enabling people to have an easier access to the actually stored graph data. without having to implement code against an API or without writing Java or Ruby or JavaScript code. We developed a query language which is declarative. It's similar to SQL in intent. So because it intends you to say what you want, not how it's been done. And it's based on pattern matching, so it tries to find the patterns you specify in a kind of SQL syntax in the graph. And the two examples here show some applications. So first, we have a starting point where Peter is looked up in the index, where we have the user index, where the username is indexed, and we have the name Peter Neubauer in there. So then we are interested we are interested in users that Peter mentions, but he doesn't follow yet. So we look at the tweets he posted. So we follow the posted relationships from from Peter to the tweet. Then from the tweets we follow the mentioned relationships to the users. And for all of these users we found, which is a two-hop traversal. And for all of the users we found, we check if they are living in Sweden and if Peter not already follows them. And if all these constraints are true, then we return the user, which would be a list of people who Peter could follow. The second query adopted something different. It shows co-appearance of tags. So we are interested, we have a tag and want to see which other tags also appear with this tag very often. So perhaps they are kind of connected. And we could actually create a connection between the tags to present this strong connectedness between these tags. Or perhaps they are synonyms, so they could be used in the same way when searching for things. So we look at the tag node, we find it in the index again. Then we look at the tweets which are tagged with this node, with this tag, and then we look which other tags does all the tweets also have, so the code tags kind of. And for all these code tags, we aggregate them, so it's like a group by operation, and count how often they appear, so that we can order by the count descending and take the top 10 of these tags, and these are the most interesting ones that co-appear with Neo4j. These are two examples of Cypher. Why is it important to know some Cypher? First, it's important to explore a graph with ad hoc queries. So imagine you have your graph and you want to do some analysis before actually coding these analytics queries. Then you can just open a console against the graph and execute these queries and then see what happens. If you were right with your assumptions, for instance, or what kind of insights you get. They're also used for ad hoc exploration, so you can just, as DBA or analyst, you can grab Cypher and analyze your graph on the fly. But they're also used as kind of an infrastructural thing. So much like SQL is used in GPA as communication protocol to the database, you can also use Cypher in the same way. So Spring Data Neo4j uses Cypher in some places to actually generate Cypher queries for certain finder methods and uses all the meta information it gets from your entities to create these Cypher methods, but I'll show that later. So, which leads us to Spring Data Neo4j itself, which is part of the Spring Data project. And the Spring Data project is an effort by Spring Source to give actually Spring developers the same convenience in data access as they have with JDBC or GPA. And so like the GDBC template gave us all lots of ease in using relational databases. The Spring Data project want to do that for NoSQL databases as well. It builds on top of common infrastructure. One of those projects is Spring Data Neo4j, and there's a master page or site on springsource.org where you can find more information, and we have more approaches covered by Spring Data There's also a book coming out. I'll speak about that at the end, I think. So Spring Data Neo4j actually was the first Spring Data project, so it's kind of the starting point of the Spring Data project itself. And Spring Data Neo4j is the brainchild of Roy Johnson and Emil Eifram, our CEO. And they were bored of not being able to code, so they got together and wrote the initial prototype, probably in some hotel bars somewhere around the world. And so our teams looked at the initial prototype and continued to develop it. So Spring Source and New Technology together worked on this to take it where it is now. And Spring Data Neo4j uses a quite simple programming model. We use annotations on entities to make them mappable to the graph. So it's much like in GPA where you annotate your photos. You also annotate your entities in SDN. And the state of these objects is backed by the graph database. We have two ways of mapping objects to the graph. First one is a simple copy out, copy in way where you say, I want this object or this object structure stored in the graph. So the library takes the object or its kind of surrounding structure as well and stores it in the graph database. And also on retrieval, it copies data out of the graph into your objects. Second mode, the advanced mode, actually provides a live view of the graph through your objects. So it uses FBJ to redirect your field accesses to graph, to node properties, or to relationship access. We also support the Spring Data repositories, which are really a neat way to not write code to get repository support. I show that in the actual coding examples. And we also support Neo4j server directly. Yeah, let's start with a look at the old days. Before SDN, you wrote your domain classes more or less like this. Probably you use some inheritance, but the approach was similar. So you put your actual node into your class, and then you redirected getter and setter access to the properties of this node. And you can easily imagine that for a lot of properties and a lot of attributes, it got quite tedious to have all this code. And even for a bigger domain, it's not so nice to maintain all this information and all this code. The SDN class looks like that. So we have one field that stores the actual ID of the node from the graph or relationship. And then we have one field which actually stores the property. And you can imagine an arbitrary number of fields there, which might be set or not. If they're not set, they will not be stored in the graph at all. So that's part of the schema-free nature. And it also converts things, for instance, like dates and enums and others with Spring conversion facilities to types that Neo4j can store. Yep, that's about it. So if you want to go further, then you can say, I want to index this tag attribute. So that allows me to ask the index to for a tag. So I can say, index, please give me the tag with this name, and then the indexing infrastructure will do that. In Neo4j, there is a simple order index, which is where you have one index for all nodes, and otherwise you have to do manual indexing. And in Spring Data Neo4j, properties are automatically indexed. So whenever you change the property, the index is updated, and if you remove the entity, then the index is cleaned, and so on. The uniqueness attribute of this index annotation is quite important because you often have the business constraint that some entities must be unique on some properties. So, for instance, a user with an email address is unique by this email address, or in our case, the tag is unique by its tag name. So this feature was added in Spring Data Neo4j 2.1. By the way, don't forget to tweet, otherwise our graph at the end will be empty. So whatever you'd like to share, please use Twitter to do that, and use the hashtags Neo4j and SDN to mark your tweets. so we can find them. Okay, to recap the annotations, it's not so much. So a thing that's important, but which I will show in a minute, is that references between to other objects or collections of objects are stored as relationships, and only primitive fields are stored as properties on the node itself. And otherwise, you can use those classes just like your usual Pojo. And something that's quite important is that the type information of your object is also stored in the graph, which enables us to either check for types if you want that, or we can actually create the correct type as return type for lookup operations even without you providing this information. And we can also do something like find all users or find all tags just derived from a type. There's also the possibility to define classes and entities for your relationships, which are sometimes necessary, sometimes not. It depends on your domain model and how you model your relationships. If you have rich relationships which also contain attributes, or if you have just the information that things are connected. If you have really rich relationships that actually are part of your domain and part of your domain model, then you would use a relationship entity to put more information into those entities. So a more advanced example, I just correct this slide. Okay. Let's see. So we have the tweet domain class, which is similar to the tag domain class that we already saw, but it contains a bit more. So we have a primitive property, which is the text, which is not indexed and nothing, it's just stored. Then we have some references. So first it's the sender, the user who posted the tweet, which is put in without any annotation. So usually you can just use the references in Spring Data Neo4j without annotating them. You just annotate them when you want to make it explicit, or if you want to configure something that's not the default. So for the user, we didn't do that. So the field name will be used as relationship type. So it's sender in this case. The @fetch annotation means that this relationship and the user at the end will be loaded eagerly when the tweet is loaded. If you don't put a fetch annotation in the simple mapping mode, then only the ID of the user is loaded, so you can fetch it later. So it's a bit like the GPA annotations for fetching data. You have to be a bit careful how to fetch data, because you can easily, especially in a graph database which is richly connected, you can easily run into circles and cascades which fetch more data than you want to. So it's oftentimes sensible to not fetch everything and only pull out the other things on demand, or use a query like the Cypher queries I showed to actually access the relevant data. The other entities that we can see in collections here are either tags or mentions, which are annotated with @related_to, and @related_to has a type attribute which allows you to specify the relationship type, where I put in the relationship types that you already saw in the domain model. I can quickly go back to the domain model so you can have another look there. So we have tweets that we saw. Let's just WebEx catch up. Come on. Okay. So we have tweets that we saw. We have the users who posted the tweets. We have the tags which have a tagged relationship type. And we have dimension between the tweet and the user. And both the tagged relationship type as well as the mentioned relationship type are represented in the entity as type attribute. So fast forward again. Let's stress WebEx bit. Okay. There you are. So that means the text mentioned and the source tweet get this special type. And whenever you put something in these collections, and save the entity, then it will be stored in the graph. So to scare you away a bit, I also put in how you would do it in the core API of Neo4j, which is much more code to write, and it's quite tedious code to write. That means you grab the node, get all the relationships of this type. In this case, it's tagged, and in a certain direction, and then you get the end nodes of these relationships and put them inside your domain classes, the tags in this case, and then you return this list of tags, which is much more code, and it's really not the nicest thing to write every time. So in Spring Data Neo4j, it's just a single that's related to entity annotation. Spring Data Neo4j also supports the repositories that I spoke about a bit. They are based on infrastructure in Spring Data Commons. And it's actually pretty neat because you just have to define an interface, nothing else, which extends the base interface, and then you can just use it out of the box for CRUD operations, for index lookups or traversals. You can add your own methods into the interface directly, and if you either annotate these methods, you can run graph queries on them, or you have derived queries, which are much like the finder methods that you perhaps know from Grails or Rails, which actually analyze the method name and then create a query from that. But I'll show it in a few minutes. So one of these repositories would look like that. So I have the tweet repository, which has a find by tweet method, which is, so you see it's just an interface which extends another interface, and the method is just a method declaration, and also the next one is just a method declaration. And these are two examples for a derived method. So it would, the infrastructure would look at the tweet class, at the meta information, and see, oh, there's a tweet ID attribute. So probably I want to create a Cypher query which just looks up this tweet ID. Oh, this is an index ID, so I can use the index to look it up. And so that's what it does. It creates a Cypher query behind the scenes to use the meta information from your classes and then executes the queries on demand. And for the second one, it actually follows a relationship. So it sees that you have a tag field, which is a relationship field, and you know the relationship type from the annotation, and you can just create a Cypher query which follows this relationship to the tags, and then you compare the tags with the name you provided as parameter here, and so you find your collection of tweets with this tag. These repositories are just set up in the config with a namespace element, and then you can inject them into your controllers or services or wherever you want to and use them. So that's quite nice. You can also extend those repositories with your own implementations, where you would put the method in the interface and then have a accompanying class which actually contains the implementation code. So it's a bit like a mix-in approach. Neo4j template is like the GDBC template, well-known pattern. It does resource and transaction management, brings along convenience methods, and handles conversion from nodes and relationships to entities and back. So that takes a lot of tedious work off your shoulders, and it has some fluent result handling built in, which saves us from providing as many methods as the GDBC template, because you do some of the result mangling with the result API. So Neo4j server support is just a configuration option. So you use a different graph database bean and put that into your Neo4j config, and that would enable you to use Neo4j server. Of course, there are some differences in how the network latency affects your program. So it's also code-wise, just a drop-in replacement. You should be aware of that and probably change some of your round trips into being server-side executed queries or traversals instead of direct operations on the entities. And yeah, a word of caution in general. Spring Data Neo4j is like all the other mapping frameworks and indirection that you add to your code base, an indirection between the database and your code. And so it's not the best solution if you do mass data handling, because then this indirection adds overhead on each call. It's more a convenience that you use for integration with UI frameworks, with other libraries, and so on. And for mass data handling, you can always drop down to the Neo4j core API and execute very fast traversals and also very fast insertions on the core level, which is much faster. But for the convenience of the programming model, it's really nice to use. That's why we go to the coding now. So we use Spring Social minimally, and we have a very simple domain that I showed several times. And we also see the usage of repositories and services and have a standalone app with the Neo4j database, which you run and see what happens. And I have a local Neo4j server, which I use for the visualization. I wanted to have the app write to Neo4j server directly, but it clashes a bit with the Jackson library that Spring Social brings along. So I have to add some abstraction in the infrastructure to take care of that, which I haven't done yet. So let's start with the simple class, the tag that we've already seen. So it doesn't look much different than the slide I showed you. Just the same things. The user is similarly simple, so it has just a user string there. And as I said, the ID is important for the library to store the Neo4j ID. It's only needed in the simple mapping mode, and whenever there is no ID in there, then Spring Data Neo4j assumes that this is a new entity and will create a node-all relationship when you save the entity. Otherwise, it will just attach it to the entity in the graph and merge the properties back that you probably changed. The tweet is a bit more involved, as you already seen. It has the text, the sender, and the text and mentions and source as well. And this tweet is used by a service to provide its value. You see, here you can also see the fetch annotations that I use, because in my use case, I don't have that many users or senders on a tweet, just one, and not that many text and mentions, so that's fine. But if I would, for instance, put a relationship like that, for instance, I would take here's the tag. There it is. So, for instance, I could put a relationship between a tweet relationship into the tag. Then I would have the means of getting all the tweets for this tag just by using this field. But we should be aware of that there could be lots of tweets on the simple tag. And secondly, we should be aware of if I have fetch on both sides of a relationship, then it actually will start to cascade and pull in much more data than intended. So that's why for things like these, I would rather use a repository operation to fetch the tweets of a tag. Which brings us actually to repositories. So we have the tag repository, and it's empty because I just used the the CRUD operations, they're nothing special. And I also have the user repository, which is similarly empty. Oops, sorry. Which is similarly empty. And we have a tweet repository, which is not as empty, but it's still an interface. So we have the tweet find by ID and find by text tag in here as demonstration. So it's very, very nice to have, not to write that much code for repositories. All this comes together in the Twitter service. So let's wait for WebEx again. There it is. All this comes together in the Twitter service, which we use from our application to pull in the tweets and import the tweets. So what we actually do is use Spring Social's search operations on Twitter, the Twitter template, and we just search for the first page of the with 200 tweets of the search term that was passed in, so the string up here that was passed in from the outside, and optionally we can provide a last tweet ID, which is used to limit the Twitter search from a certain tweet, so that we don't get all the history if you're not interested in that. So we have a slight name clash because, of course, Spring Social also calls it tweets, so that's why the fully qualified name is here. And for each of the tweets, we just call import. And what we actually do is we extract information from the social tweet from Spring Social and create the appropriate entities in our domain for that. So we start by finding the poster of this tweet, the person who sent the tweet. We create a user with this name and save it. And the uniqueness index here will take care of duplicate entries. So whenever there was already an entry with this name, we just return it, and there's no duplication happening. So it's aware of the uniqueness constraint here. So we get back our user. We create a tweet from the tweet ID, the user, and the text of the tweet, which is just a constructor which sets these two properties and one reference. The sender is the reference, so which would result into a relationship being created. And then we also add dimensions and the text, and because I didn't find anything in Spring Social to extract mentions and text from a tweet, I just used a critical expression for extracting those, so something like that. And for each of the mentions and each of the tags, I just either create a tag and save it with the tag repository, or I do the same with the user, which the tweet meant. We just add these to the tweet, and these add methods just add these things to the collections that we saw, and as last operation, we save this tweet, and when the tweet repository saves the tweet, which actually just delegates to the template to do the storage and the merging. When we save the tweet, then the node is created because there was no graph ID in the graph ID field. Properties like text is set, and relationships to the posting user, to the tag relationship, and to the mentioned users are created. So whenever we run this, then we get a tweet with outgoing connections to the user who posted it, to the tags, and to the mentioned users as well. So that's a very simple application for pulling in non-graph data into a graph database. And now let's see if you were really busy tweeting about this webinar. I just want to run it, the application, and see if I broke anything. And then you see if Twitter works. So we just use the setup, which I can show in a minute. So we have some tweets here, and we will look at those immediately. So I forgot to show you the main application, which is very simple, which just gets the Spring context, gets the service bean, and then runs the import tweets method that we just saw in a while loop and sleeps for 5 minutes after that. And we just extract the maximum tweet ID to be the new limit for the next search, so we don't do too much work in general. Okay, and if we take the graph, so I just stop this application here and copy the database to the Neo4j server that I have locally and start it. Then we can have a look at the data. So you can also run the Neo4j server infrastructure on top of your embedded database. So I just downloaded Neo4j server from neo4j.org and unzipped and started it and put in the graph that we just created. And if you look at the database, let's see, that was from the first webinar. I just run this. So we have now people here who send tweets, and those tweets have tags. And you can see that there are 26 nodes connected to the SDN tag, and there are lots of tweets connected to the Neo4j tag. And then you can continue to explore these tweets to see which other users are here and which other tags are here, who mentioned whom, and so on. And so on top of this graph, we can now start to analyze this data and find, for instance, implicit connections between people, implicit connections between tags. We can find influential people. We can find trending topics. We can do a lot of interesting operations on top of this graph data. And you saw that it's very simple to write an application to just take Twitter stream and pull it in, and there's much more that you can do. For instance, also pulling out things like URLs and putting them into the graph as well, so you see which, for instance, which resources are also interesting to people because many people mention them in their tweets, or which people found which resources by which tweets because they retweeted it later also. And there are countless opportunities to explore this data and make it possible to use it in your application. And Alison wants to know where her tweet is. So let's see if you find it. So we can use a index query. So I hope I didn't mistype that. No. Okay. Node user. Let's see, username. So let's write some Cypher query and see if that returns something. No, we don't find it. Perhaps I just mistyped it. Or it's not called username, just user. Found one row. Let's see if you can see that one. It doesn't show it. Node 15. So there she is. We have 3 tags, 2 tags, 1 mention, and then we have other people who mentioned my tweet and so on. Cool. Yeah, that's about it from me. I have some more slides for how to follow up with that. So there's much more to learn than I could cover in this short time. So you can grab the free ebook on Spring Data Neo4j from InfoQ. There's also a printed version now, which has lots of content and a walkthrough example for Cineasts.net, which is, I'm sorry. So here's the InfoQ Spring Data Neo4j book, and there's Cineasts.net, which is a social movie database built with SDN, and it walks through the example how to build such a movie database. And then, as I mentioned, there's also the book by the Spring project leads about the Spring Data project, which is right now in early access from O'Reilly, which is really nice. And in general, there are lots of resources that you can use for exploring this area further. So being at either Neo4j or Spring Data Neo4j, we have lots of videos and local meetup groups. So whenever you don't find a local meetup group, just contact us and we try to make something happen there. That's about it from my side. I would like to have a look at the questions, if there are any open questions. Let's see, I start at the end. And I see that Lasse already answered most of them or all of them, I think. Okay, I think we are done now. And I put up the where to continue slide. You find lots of information there, and you can also join either the Neo4j mailing list, the Google group, or the Spring forums for more questions, and feel free to ask whatever you're interested in, and we try to answer them as soon as possible. Right now, it's quite strongly connected to the Spring framework. We had some requests of pulling this out of Spring, but we have found time to do that. It might change in the future when we do some infrastructure changes, that it gets easier to pull it out, but right now it's not there. And especially all the infrastructure for the meta information and the repositories comes out of Spring Data Commons anyway. So that's right now it would be an exercise for you to do it. And but I think it's not so hard, and if you don't use Spring. And there are also other ways. So for instance, we wrote also applications that use Cypher almost exclusively, and then it also becomes quite easy to write an application for that. Okay, thanks a lot for your attendance. I really enjoyed that you were here. And as I said, you can reach out and find us on lots of channels. And thanks for joining us today and being here.